In today's lesson, we are going to be looking at going from getting equations from tables. Before we want to do that, though, we want to figure out or look at tables of rules and patterns, and look to see if there's any kind of common things that we can look for, or kind of key properties of the patterns that we can see within the table itself. So just a reminder, for all linear relations or all linear kind of patterns, we generally represent it with the rule y equals mx plus b. So here, the m tends to represent, we usually refer to it as the multiplier, and b is commonly referred to as the constant. You might think of it as maybe the base or initial value. And x represents the independent variable, and y represents the dependent variable. So independent would be something that isn't affected by anything, so it might be something like hours worked, and the dependent would be something that is affected or relies or is dependent on the x value, which would be the total earnings, right? So your hours worked doesn't depend on how much you earn. How much you earn depends on how many hours you have worked. You can think of it that way. But right now we're going to look mostly just in terms of x and y. So what we want to do right now is going from tables to equations. And we want to figure out or fill in the table based off of what each equation is. So we have y equals 5x. So in this case, in this equation, we are going to just replace the x with a value. And we have a list of values that we're going to use. So in the first one, we're going to replace it with 0. So what we can do is, just for example, we can take y equals 5x, replace the x with 0, so it becomes 5 times 0, right? Going back to our equation unit, variable in a letter, or variable in a number, we multiply. So 5 times 0, which is 0. For the next one, y equals 5x, or 5 times 1, which is 5 times 5, or 5 times 1, which is 5. The next one, 5 times 2, which is 10, 5 times 3, which is 15, and then 20. So if we start to see a pattern. The next one, y equals 10x plus 5. So a little bit different, but same idea. We're going to take the value of x and substitute it in. So 10 times 0 plus 5. 10 times 0 is 0, plus 5 is 5. So we have 5. Y equals, or x equals 1. So we have 10 times 1 plus 5. 10 times 1 is 10, plus 5 is 15. Now we have 5, 15. You might be able to recognize the pattern and use the rule to help us figure out what the next spot is, or the next value is. If not, again, you can continue to substitute. 10 times 2 plus 5, we have 20 plus 5, and 25. Hopefully you've recognized the pattern, though, and recognize the next one is going to be 35, and then 45. So where do we see these values in the table represented in our equation? Well, if we look at number 2 might be a little bit easier because we can see everything there. Number 2, I can see, well, 0 and 5, I can see that. I can see my 5 in the equation. I can see that that's when x equals 0. Now, what about the 10? Where do we see the 10 appearing? Well, the 10 we see appearing as we increase. We're going up by 10, from 5 to 15, from 15 to 25, from 25 to 35, from 35 to 45. That's an increase of 10 every time. So we can see that in our equation. We can see that attached to the variable. Let's go back to the first one. Where do we see it in the first one? Well, I see 0 and 0. So similar spot in the table. Where do I see that in our equation? Well, where do we see 0 in the equation? A little bit tougher because we don't normally see 0, but if we look to see where the 5 was in number 2, what's added on? Well, nothing is added on, right? So that's where we could see the 0. Nothing is added on after the 5x. Where do we see the 5? Well, again, if you kind of look similar to number 2, we can see that we're increasing by 5 every time. So this plus 5 is again appearing with the x. And we'll make the connection with the actual values. We just want to see where do we see these values, or with actual terms. We just want to start to see where do we see these values appearing in our table. Let's look at another one. Negative 2x plus 10. So again, we're going to do the same thing. We have our table of values. We want to plug those in, or plug the x values in to our equation and solve. So negative 2 times 0 plus 10. Negative 2 times 0 is 0, plus 10 is 10. So the first one is 10. The next one, negative 2 times 1 plus 10. So negative 2 plus 10 is 8. Next spot, negative 2 times 2 plus 10. Negative 4 plus 10 is 6. Do we start to see a pattern? Could you guess what the next value is going to be? If you guessed 4, you were correct. And if you guessed 2, you were correct. So again, where do we see the values of the equation in this table? Well, I can see 10. 10 occurs when x is 0. Where do I see the negative 2 in the equation? Well, what's happening to my numbers? As I'm increasing a position, as I'm increasing every 1, I go up 1 position, I see that my value, or my y value, is decreasing by 2 every time. So this minus 2 appears as what my pattern is changing by every time. And again, we've made that connection to the pattern changing to be the m value, but now we're seeing it in the table. What about number 4? A little bit different of equation, 0.5x, so a decimal. Again, we're going to fill out our table of values. So 0.5 times 0 gives us 0. Okay. Oh, my x value is 2. It's not 1. Okay. That's not going to change anything. 0.5 times 2 equals 1. I don't have to add anything, so it'll be 1. 0.5 times 4 is 2. 0.5 times 6 is 3, or you can start to see a pattern. 8 times 0.5 is 4. Let's look to see if we can find those same values from our equation. Well, first one's easy, 0 and 0. We kind of talked about that, similar to the last one. I would have a plus 0 on the end here. That's where I can see this 0. Where do I see the 0.5 though? I don't see 0.5 appearing anywhere in our table. Well, if we look to the previous examples of where we saw that this value in front of the x occur, that would normally be what my y values are increasing by. But we can see that it's not increasing by 0.5. This is increasing by 1. And by 1 again. And by 1 again. And by 1 again. Right? So that's not quite the 0.5. So where would the 0.5 come into play? What's different about this one? Well, you might have noticed that we're not going up by 1 position anymore. We're not looking at every single position. We're skipping 1. We're skipping the whole middle position, or one whole position. So my x values are actually increasing by 2 every time, which is different from some of the other ones. And this is important because this is where we're going to see our 0.5. So if I'm increasing 1 value for every 2 positions, That means I'm increasing actually 0.5 for every one position. So if I was to look at actual position 1, I would see 0.5. If I look at position 3, I'd see 1.5. So that's where I'd see the 0.5 come into play. For every single position, it's going up by a half. But just to make things easier, the table isn't showing me every single position. It's only showing me every whole value. So you want to be careful because sometimes you might not see it directly. You will have to do a small calculation to identify it. So in summary, looking at those tables, where do we see these values or these terms or these parts of our rule or linear relationship? Well, again, the m, we refer to the multiplier. The b, we talked about being the constant, or you might hear it as the base or initial or starting value, which is all good for our patterns. But now when we look at the table, where do we see this? Right? It still has the same terms, but we're gonna look in different spots. We're gonna refer to it differently. So start off the easy one. For b, that b value, that constant, whatever we're adding at the end, this occurs, or we see this when x equals 0, or the y value when x equals 0. So we see it when x equals 0, specifically the y value when x equals 0. You could think of it as, again, the starting value, things like that. The m, still the multiplier, but where do we see it in the table? Right? If we go back, we see it's what the y value is going up by. More specifically, though, it's what the y value is going up by for every one position. So what the y value changes by for every one x increase. We do have a new formula that we can use to help solve or calculate it, and that would be the change in y divided by the change in x. So this is a new formula that we can use. To help us calculate the multiplier. In some cases, you might be able to recognize the pattern. You may not need to use that formula. If not, that's a good formula to always kind of use and stick with. And I'm actually just going to highlight that all and make it red because we tend to represent it mostly in red when we go through our examples. So the change in y divided by the change in x, that tells us what the y value changes by for every one x increase, or it tells us the multiplier. So now what we're going to do, now we're going to go from the table and work our way back to the equation. So we need to kind of reverse this. We're basically going to be reversing what we've done. So we're looking for those kind of key concepts, right? We're looking for the multiplier, or the m value, which is the change in y when x increases by 1, or what the y value increases by or changes by. And we're looking for the b value, which is the constant or the y-intercept. It's the y value or the value of y when x equals 0. So let's look at our first one. Well, our first one is easy. We see that constant right off the bat, right? Use a different color, keep it a little more consistent. So we see when x equals 0, y is 4. So that tells us that our equation is going to have a plus 4 at the end. Next, we have to find our multiplier. So what are our y values changing by? Well, we can see that they're going up from 4 to 9. That's an increase of 5. From 9 to 14, that's an increase of 5. From 14 to 19, again, an increase of 5. I could look at the last one, but again, I'm starting to see the pattern. One thing we do want to make sure, though, is are the x values increasing by 1? Is it 5, an increase of 5 for every one position? In this case, yes, it is. So that means my m value is going to be 5. Or if I want to calculate change in y changes by 5, divided by the change in x, which is changing by 1, which equals 5. So my equation is going to be y equals 5x plus 4. Let's look at example 2. Again, easy one to usually find is when x is 0. I see it right there. I see x is 0. That tells me the y is 0. Or the b value, the constant. So plus 0. Now I need to look for my multiplier. Here I'm increasing by 3, increasing by 3, increasing by 3, increasing by 3. Again, you don't need to do all of them once you start to recognize the pattern, as long as it stays the same throughout. If it only does it for 2 and then it changes for the other 2, it's not your multiplier. And chances are it's not linear. We also want to double check, are the x values going up by 1? In this case, they are. This saves us from having to do any extra calculations. If we wanted to, we could. The change in y changes by 3, divided by 1, the change in x, which equals 3. Either way, that's our m value. So when y changes, or when the x values change by 1, we don't really have to actually calculate it or do any division. It will be helpful. It is a helpful step to think about, though, especially when we get into scenarios where the x doesn't change by 1. So in this case, our rule is going to be y equals 3x plus 0. Do we have to show the 0? No, we don't. Adding 0 isn't going to do anything. So we could just leave it as y equals 3x. We don't need to show that plus 0. It's helpful, again, because we want to always consider that there is a constant, or that we have a spot there. There's not necessarily always going to be a value there. Take a look at 2 more. So looking at 3, I don't see any x equals 0. So let's skip looking for the constant right now, and let's look for the multiplier. So what do the y values change by? Well, they increase. The pattern looks like they're increasing by 2. And just to confirm, the x values are also increasing by 1. So I know that my multiplier is going to be change in y, which is 2, divided by the change in x, which is 1. 2 divided by 1 is 2. Again, I don't need to do that calculation, but it's just a good habit to get into. So my multiplier is 2, so I know right now I will have a 2x. I don't know what my constant is, though. And there are different ways that you can go about calculating this. You could look at the pattern and say, okay, well, if I'm increasing by 2 every time, what would happen if I go backwards? Because I'm looking for x equals 0. That's only one spot back. Right? I'm only looking for x equals 0. So that's only one spot back from 1. So what would the y value then be when I change, or when I go backwards? I'm going back by 1 position here, so I'm subtracting 1. What would happen on the y side? Well, I know the pattern to increase as I increase positions is plus 2. So then going backwards, well, I just reverse that, which is minus 2. So 10 minus 2 gives me 8. So that tells me what my constant is going to be, or my b value, my y-intercept. So my y-intercept is actually going to be plus 8. So you may not see the constant, the b value, the y-intercept when x equals 0, but if it's a nice pattern and you're close and you have x values that are close to 0, you can always just work backwards, reverse your pattern to get back to 0. Another thing you could do, you could use the idea of filling in your rule. So if we know, let me just move this up. If we know that our multiplier, we are going to be multiplying our x values. So if I look at the first example, I'm going to multiply 1 times 2, and then that plus something should equal 10, right? Because this is my y value. So 1 times 2 should give me 10. It does not, right? 1 times 2 equals 2. So that means 2 plus something, or 2 minus something, whatever the case may be, has to equal 10. Well, in this case, 2 plus 8 equals 10. So that 8 is our constant, or our b value. So different ways we could work through it. Right? We could use our table of values to kind of help us figure out what that constant is going to be, or we can use the pattern and work backwards. Number 4. So again, this one's nice and easy, at least for the first part. I see my constant right away. I see x is 0, tells me that y is positive 25. The only thing now we have to figure out is our multiplier. What are the y values changing by? Well, 25 to 21, that's a decrease of 4, so minus 4. 21 to 17, decrease of 4 again, minus 4. You could go do the next one, minus 4, so on and so on. Double check that the x's are increasing by 1. In this case, they are. You could just do the quick calculation, m equals negative 4, which is your change in y, divided by 1, which is your change in x, which gives you just negative 4. So this tells me that my pattern is decreasing. So I have a negative 4x plus 5. So I'm starting at 5 and I'm 25 and I'm decreasing by 4 every time my position goes up. Two more examples will get a little bit trickier. So if I look at 5, I have a table. I don't see x equals 0. So in this one, we might have to do a little bit of work, but let's at least look for our multiplier. What are the y values changing by? Well, from 32 to 37, this is increasing by 5. From 37 to 42, that's also increasing by 5. I could look at the next two, or I can, again, looking at a linear pattern, so it's all increasing by 5. Double check that the x's are increasing by 1. In this case, they are. I could just do the quick calculation just to confirm. 5 divided by 1, change in y divided by change in x, which is 5. So right now I know for my rule, y equals 5x. I don't know what my constant is, though. I don't know what that b value is. Now, because we know what we're changing by every single position, I could work backwards. I could work backwards to position 4, then 3, then 2, then 1, then 0, but that might require a lot of work. It's possible, right? Because I work backwards, so I go back to position 4, I subtract 5, so I'm going back one position, I reverse my pattern, so I get to 27, go back by 5 again, I get back to 22, I go back to position 3, or that's position 3, then position 2, then 1, then 0, which isn't impossible. You could do it that way. A little bit more work required and more time. What we could do, though, is similar to what we kind of did on the last one. Let's use our table to help us and use our knowledge of the rule. We know we're going to be multiplying each x value by the multiplier. So we know we're going to take 5, which is our multiplier, multiply it by, in our case, our first x value, which is 5. and we get 25. That's not quite our y value in the table. So we know that 25 plus something has to equal 32, which is our y value. So we've multiplied our x value by the multiplier. We need to do something else to it to get to our y value. So 25 plus what equals 32? Again, you could solve for it. You could reason through it. 25 plus 7 is 32. So that has to be our constant. So that means our rule is going to be 25 or 5x plus 7. Now you could double check that. You could go back and look at the next one, say, okay, 6 times 5 is 30. 30 plus 7 equals 37. Okay, that works. That means that my constant has to be 7. You could again continue that pattern backwards and you'd recognize that you would get 7 as well. So if you don't see the constant in your table and it's a little bit too far to work backwards, you can always use kind of an application of the rule to solve or to find that missing piece. What is that missing piece we have to add or subtract to get to that y value? Now, number 6. 6 is probably one of the more challenging ones that we'll see. Looking at it, it is blank, or we have blanks, we have empty spots. So what we need to do here is we need to go through and fill it in. But in order to do that, we need our rule. So let's take a look. Do we see our x value, or do we see x equals 0? No. So we're going to need to look for our multiplier. Do we see every single spot? We do not. So in this case, we are going to have to really focus on using the application of our rule, or our new rule for our multiplier, which is the change in y divided by the change in x. So let's look at 2 spots. What are the y values changing by? Well, here, these are the only 2 y values where we know the x values. So let's take a look at what they're changing by. From 2 to 4, that's an increase of 2. Now let's look at what the x values are increasing by. 2 to 6, that's an increase of 4. So that means that for every 4 positions, the y value increases by 2. So let's use our formula. M equals, give ourselves some space. So M equals, let me just make that a little bit neater. So M equals change in y. And again, we had this formula before. This is what we were doing all along. But now, because we have different values, we're not increasing for every one. It's going to be really imperative that we use this formula, change in x. So the y values, from 2 to 4, it's increasing by 2. Divided by the change in x. From these 2 points, from this change of y, we see a change in x of 4. Right? So we want to make it consistent. We're not going to go from 2 to 4 because we're not looking at those 2 values. We're looking at these 2 values, or these 2 pairs. So we get 2 divided by 4, which is 1/2, or 0.5. So that means for my rule, right now it's going to be y equals 1/2 x plus a value. So we still need to figure out our constant. And again, that's where using that little rule that we looked at, or a little application of our rule. Let's take our x value, or let's take an x value and multiply it by the multiplier. So 1/2 times 2, which is our x value, equals 1. So then 1 plus something has to equal 2, or our y value. Right? Just taking that straight from the table, right? Just taking these 2 points here from the table, multiplying by 2, or the x value by 1/2, needs to work out to 2. So I need to add something to it. In this case, it will be 1. 1 plus 1 equals 2. So then to finish off my rule, 1/2 x plus 1. And you can go through and double check. Looking at 6. 6 times a half is 3, plus 1 is 4. So that does work. And we can use that to fill in the missing values. I can fill in this value because 4 times, change the size. So 1/2 times 4 equals 2. And then add 1, so 2 plus 1 is 3. 8 times a half, or 1/2 times 8, plus 1, so 4 plus 1, which is 5. And with making the jump up to 15, so we do have to work backwards in a way, so we kind of reverse our pattern. So we take away 1, so 15 minus 1 is 14. 14 divided in half is 7. Right, so 15 minus 1 equals 14, and then 14 divided by 2 equals 7. So you can work backwards, or basically solve the equation. So depending on what we're given, if we're given to it in a table, we have to, again, look for two key things. Look for the multiplier, what the y value is changing by for every one change in x. We may have to use a formula if it's not changing by 1 every time. So we might have to do a calculation like we just did. And we're looking for the constant, which is when x equals 0. We may have to use our understanding of the rule to find it, or reverse our pattern and work backwards. So either way we choose to do that, we should be able to calculate our rule. Again, the only two values we're trying to fill in are the m and the b value. The y and the x stay the same. They're representing unknown values, or an infinite amount of values. So we just want to be careful. We don't replace y and x, only the m and b when we're creating our rule. We can sub values in when we're making calculations, but we're not replacing the y and x.